First question of exercise 3.4. We need to divide a polynomial p of x by another polynomial g of x and find the quotient and remainder of the following 1 to 1 to and 3. So simply before dividing polynomials, if we let's say we divide a number example 10 with the number 3 and we need to multiply some number to 3 which is closest to 10, right? So we multiply 3 threes are 9 and we subtract the 9 from the 10. So we change the sign from plus 9 to minus 9 and write the remainder as 1. In the similar way, when we are dividing two polynomials, p of x and g of x, we need to multiply a term to the g of x and to subtract from the p of x. So let's take an example here. If we have the first one, p of x equal to x cube minus 3x square plus 5x minus 3, and g of x we have x square minus 2. So in that case, we multiplied 3 with 3. In this case, what do we need to multiply? So to divide polynomials, we have to multiply a term to g of x, which is equal to the p of x. So listen carefully. We need to multiply a term to first term of g of x that should be equal to first term of p of x. So we have first term of p of x equal to x cube, and we need to multiply something to g of x first term, which is x square, to get x cube. What do we need to multiply? We need to multiply x. So at side we'll write q of x here. So that will be x. So we multiply x with all terms of g of x. So we have x into x square is x cube. Next, minus 2 into x is minus 2x. Let's write it here below 5x. And since there is no x square term, let's replace it with 0 x square. So after writing 3 into 3 equal to 9, we change the sign from plus 9 to minus 9 to subtract it. In the same way here, we change the signs. So we have plus x cube is replaced with minus x cube, and 0x square plus will be minus, and minus 2x will be plus 2x. Now consider all the new signs of the equation. So x cube minus x cube would be 0, minus 3x square minus 0x square would be minus 3x square, and 5x plus 2x would be 7x. Next, the division is not complete. Next, what do we multiply to the first term of g of x to get the first term of p of x? Here we have first term of p of x is minus 3x square. So I would multiply minus 3 to get the first term. So q of x will be this. So if I multiply minus 3 to the all terms of g of x, I would get, what would I get? So x square into minus 3 is minus 3x square. Next, minus 2 into minus 3 is plus 6. So I would write below the constant term. Since there is no x term, this will be plus 0x. And now change all the signs. This would be plus, this would be minus, this would be minus. So minus 3x square plus 3x square would be 0. 7x minus 0x would be 7x. And minus 3 minus 6 would be minus 9. So quotient is, we got it as x minus 3, and remainder would be 7x minus 9. Now let's see the second question. We have p of x equal to x power 4 minus 3x square plus 4x plus 5. G of x would be x square plus 1 minus x. Same. Let's write q of x here. So what would that be? So similar to the previous question, what do we need to multiply to the first term of q of x to get first term of p of x? So first term of p of x is x power 4, and first term of g of x is x square. So we need to multiply x square to the first term of g of x to get p of x. So first term of q of x will be x square. Multiply x square with all the terms of g of x. So we have x square at x square is x power 4, and minus x into x square is minus x cube. I wrote 0x cube in the p of x since there is no term for x cube in the p of x. So this will be minus x cube, and plus 1 into x square is plus x square. Now change the signs. This would be minus, this would be plus, this would be minus. and my x power 4 minus x power 4 is 0. 0 x cube plus x cube is x cube, minus 3x square minus x square is minus 4x square. Bring this term down, 4x. And now same, what do we need to multiply to x square to get x cube? Simply we need to multiply with x. So plus x, and now we multiply all the terms with x of g of x. So this would be x cube minus x into x is multiplying with x, right? So minus x into x is minus x square. Next 1 into x is x. Now change the signs. This would be minus, this would be plus, and this would be minus. This is 0. And minus 4x square plus x square is minus 3x square. 4x minus x is plus 3x, and bring this 5 down here. So this will be plus 5. And now we have minus x cube. What do we need to multiply to x square to make it minus 3x square? We need to multiply by minus 3. So this would be minus 3x square and plus 3x and minus 3. So change the signs. This would be plus, this would be minus, and this would be plus. 3x square plus 3x square is 0. 3x minus 3x 0. And 5 plus 3 is 8. So q of x, what we get here? Q of x equal to x square plus x minus 3. X square plus x minus 3. And remainder we got is 8. So let's see the last one. P of x, we have x power 4 minus 5x plus 6, and g of x equal to 2 minus x square. So I replaced the x cube term and x square term with 0 since they are not present in the equation. Similarly, we write q of x here. So what do we get? We need to multiply something to minus x square to get x power 4. Firstly, we need to multiply minus to the x square, so since to get positive. So if I multiply minus x square, I would get x power 4, right? So first term would be minus x square, and multiply every term with minus x square, you would get x power 4, and 2 into minus x square is minus 2x square, no x cube, so this would be 0x cube. Change the signs, minus minus, and this would be plus. Now x square, x power 4 minus x power 4 is 0, 0, this will be 0. And we have 0x square plus 2x square, this would be 2x square. And let's bring these both terms here, minus 5x plus 6. Next, what do we need to multiply to minus x square to get 2x square? We need to multiply minus 2, right? So if I multiply by minus 2 into minus x square, I would get 2x square. So this will be 2x square, uh, and plus 2 into minus 2 is minus 4, and this would be 0x. And again change the sign, this would be minus, this would be minus, this would be plus. So 0 minus 5x and 6 plus 4 is 10. So that's it. Q of x would be minus x square minus 2, and r of x would be minus 5x plus 10. Simple method. First, we need to find a term that should be multiplied to the first term of g of x to get the first term of p of x. Next, multiply all the terms with that found term. Change the signs. If it is plus, change it to minus. If it is minus, change it to plus, and add them, and repeat the procedure until you get the degree of the remainder less than degree of the g of x. As long as degree of remainder is greater than degree of g of x, you can still divide it. If we can see here, in the third question, degree is 1 and degree of g of x is 2. In the second question, the degree is 0 and degree of g of x equal to 2. And next we have degree is equal to 1 and degree equal to 2. So divide as long as the degree of remainder is less than degree of g of x. So the first step, we multiply something to g of x to get to the first term of g of x to get first term of p of x. Next, We change the signs to add all of them, and we add and find the remainder as long as the remainder of remainder the degree of remainder is less than degree of dividend. The second question of exercise 3.4, we need to check in which cases the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. In the firstly, why are they asking us to divide the second polynomial with the first polynomial? Because if the remainder is equal to 0 when we divide two numbers, then it is a factor of. So let's take an example. Let's take 9 and we divide by 3. 3 threes are 9, remainder is 0. So 3 is a factor of 9. And let's take 10, divide by 3. 3 threes are minus 9, we would get remainder equal to 1. Since remainder is not equal to 0, 3 is not a factor of 10. 3 is a factor of 9 because we got remainder as 0. So to find if a number is a factor of any other number, we need to divide and check if the remainder is 0 or not. If remainder is 0, it is factor, and if remainder is not equal to 0, it is not factor. So it is same in the case of the polynomials also. When we divide polynomials and remainder is 0, then it's a factor of the polynomial. And if remainder is not equal to 0, then it's not factor of the polynomial. In the first case, we have p of t is equal to 2t power 4 plus 3t cube minus 2t square minus 90 minus 12, and g of t is equal to t square minus 3. So to divide two polynomials, we have three rules if you have seen my last one. First, find a term to be multiplied to the first term of g of x to get first term of p of x. Next, we multiply the term to all that equation of g of x, and next we change the signs from plus to minus and minus to plus and add them and continue the process till the what do we say, the degree of remainder is less than degree of the divisor. So in this case, let's write the quotient here at side. Q of t is equal to, so a term to be multiplied to the first term of g of x to get first term of p of x. So we have g of t here, t square, I have first term, and I have to some multiply something to get 2 into t power 4. So I would multiply 2t square, right? Sorry, 2t square. If I multiply 2t square to the first term, which is t square, I would get 2t power 4. So let's multiply 2t square to all terms of g of x, right? So 2t square into t square is 2t power 4, and minus 3 into 2t square would be minus 6t square. So let's write it here. And since there is no t cube term, replace with 0t cube. Next rule, change the signs. This is plus, this would be minus, this would be minus, then this would be plus. So 2t power 4 minus 2t power 4 would be 0. 3t cube minus 0t cube would be 3t cube only. And minus 2t square plus 6t square would be plus 4t square. Bring this down, minus 90. Next, we have first term of p of x is 3t cube and first term is of g of x is t square. Let's multiply 3t to g of x first term to get 3t square, 3t cube, right? So next term would be plus 3t. So multiply 3t with all terms of g of x. 3t into t square is 3t cube, and minus 3 into 3t is minus 90. So this would be plus 0t. Since there is 0t square, since there is not t square term. Now change the sign. This would minus, this would minus, this would be plus. So 3t cube minus 3t square is 0. 4t square, so this would be 4t square. And minus 90 plus 90 is 0. And bring down the minus 12 term. Next term, what would you multiply? This would be square. Yeah. So what number would be multiplied to t square to it to become 4t square? So simply 4. So q of t would be plus 4. And if you multiply with 4, we would get 4t square minus 12. Now we subtract it, we change the sign, this should be minus, this should be plus, and we will get 0 as remainder. When we divided p of t with g of t, we got remainder as 0. Therefore, t square minus 3 is a factor of the polynomial. Next question we have p of x equal to 3x power 4 plus 5x cube minus 7x square plus 2x plus 2. And g of x we have x square minus plus 3x plus 1. Similarly, let's write q of x here, or let's write above the line without any indication. So what is the number we need to multiply to 3x square to it to become 3x power 4? So we need to multiply 3x square, right? If you multiply 3x square into x square, you will get 3x power 4. So the first term, multiply all the terms of g of x with 3x square. So we'd get 3x power 4 plus 9x cube plus 3x square. Now change all the signs. This would be minus, this would be minus, this would be minus. Next, 3x power 4 minus 3x power 4 is 0. 5x cube minus 9x cube is minus 4x cube. And minus 7x square minus 3x square is minus 10x square. Bring this term down, plus 2x. Next, what is the term? We need to multiply 2x square to it to become minus 4x cube. Obviously, we would multiply minus 4x. If you multiply minus 4x to x square, it would become minus 4x cube. So minus 4x. So if you multiply minus 4x to all the terms of the g of x, you would get minus 4x cube minus 12x square and minus 4x. So now change all the signs. This would be plus, this would be plus, this would be also be plus. So minus 4x cube plus 4x cube 0. Minus 10x square plus 12x square is 2x square. 2x plus 4x is 6x. And bring down the 2 here. We have plus 2. Next, what is the term number we multiplied to the first term of p of x to the first term to get so we multiply plus 2 here to get the first term of p of x. So 2 into x square is 2x square, and 3x into 2 is plus 6x, and 1 into 2 is 2. Now we change the signs, minus 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 and 0 0 0. Since when divided 3x power 4 plus 5x cube minus 7x square plus 2x plus 2 by x square plus 3x plus 1, we got remainder as 0. x square minus x square plus 3x plus 1 is a factor of the polynomial. Next, last one we have, let p of x equal to x power 5 plus 0x power 4, since there is no 0x power 4 in the question, minus 4x cube plus x square plus 3x plus 1, and g of x equal to x cube plus 0x square minus 3x plus 1. So similarly, what is the number we need to multiply to the first term of g of x to get the first term of p of x? It is x square. So let's write x square here. So multiply all terms with x square, we would get x power 5 plus 0x power 4, since we don't have x square term here. Next we have minus 3x cube plus x square. So when we divide it, change the signs, this minus minus plus, and this would be minus. So x power 4 minus x power 5 0. This would be 0. Plus 4x cube plus minus 4x cube plus 3x cube is equal to minus x cube, and this should also be 0. Next, bring this down here, 3x, and let's bring this also down here, plus 1. So what is the number we need to multiply to the first term of g of x to get first term of p of x? It would be minus 1. So let's write minus 1 here and multiply minus 1 to x cube. You would get minus x cube. Next, minus 3x into minus 1 is plus 3x, and 1 into minus 1 is minus 1. Now change the signs. This would be plus, this would be minus, this would be plus. Now this is 0, but 1 plus 1 is 2. Therefore, x square minus x cube minus 3x plus 1 is not a factor of x power 5 minus x cube plus x square plus 3x plus 1, because the remainder we got is plus 2. So simply first write p of x, write g of x, and multiply to find a number which is to be find a term which is to multiply the first term of g of x to get the first term of p of x. Multiply all the terms of the g of x and change all the signs from plus to minus and minus to plus. Add them and repeat the process till you get the remainder. If you get remainder equal to 0, it is a factor of polynomial. And if you not get 0 and another number like 2, then the p of x, sorry, g of x is not a factor of p of x. The third question of exercise 3.4, we need to obtain all the other zeros of this polynomial 3x power 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root 5 by 3 and minus root 5 by 3. So before jumping into this question, let us see an example here. Let's say we have a quadratic polynomial x square minus 5x plus 6. If we factorize this by dividing the middle term and all, the factors you would get are x minus 2 into x minus 3. From this, we would say that 2 and 3 are the zeros of this quadratic polynomial. So, another thing we can conclude from this is x minus 2 is a factor of the quadratic polynomial, and x minus 3 is also a factor of quadratic polynomial. So, if I divide the quadratic polynomial by x minus 2, if I say that 2 is the zero of this quadratic polynomial, find the other zero, I would divide the quadratic polynomial by x minus 2, and the quotient is what I would get, x minus 3. So, by dividing a quadratic polynomial by one of its factors, the quotient will be the other zeros of the polynomial. So, if we use the same concept in this problem, so question number 3, they told us root 5 by 3 and minus root 5 by 3 are the zeros of this biquadratic equation. So if I write them in factors, so this would be x minus root 5 by 3 and the second one would be x plus root 5 by 3, right? So I'm going to divide the biquadratic equation with this 2. Instead of dividing it 2 times, I'm going to multiply these two expressions and divide it at the one at the same time. So we have x a plus b into a minus b here, so it would be a square minus b square. So this would be x square minus 5 by 3, right? So if I divide the given biquadratic equation with x square minus 5 by 3, the quotient which I would get would be the other zeros of the polynomial, right? So let's see. So we have 3x power 4 plus 6x cube minus 2x square minus 10x minus 5. We need to divide with x square minus 5 by 3. So as I told you before, the how do we divide? We have three steps. First, we need to see what the term that's need to be multiplied to the first term of the g of x, that's the divisor, to get the first term of p of x. So I would multiply 3x square, right? So if I multiply 3x square to the first term of g of x, I would get first term of p of x, right? So 3x square into x square is 3x power 4, and minus 5 by 3 into 3x square is minus 5x square, right? So 3 would get cancelled and this would be 0x cube, right? Next step is we change all the signs. This would be minus, this would be minus, this would be plus, and now add. So this should be 0. 6x cube minus 0x cube is still 6x cube, and minus 2x square plus 5x square is 3x square. So right, so this should be 3x square. I bring this down, minus 10x. So next, what would I multiply to the first term of g of x to get first term of p of x? Now I would multiply 6x, right? 6x I would multiply. Next, if I multiply and write all the terms of, so 6x into x square is 6x square, 6x cube, sorry. And minus 5 by 3 into 6x. So if I write it beside here, minus 5 by 3 into 6x, this will cancel 2 times. So it would be minus 10x, right? So this would be minus 10x. and this would be 0 x square. Now change the signs, minus minus plus. This would get cancelled. This would be 0 x square, so 3x square. So plus 10x minus 10x would be 0. And last we have minus 5 here. So next what would I multiply? I would multiply 3. So plus 3. So x square into 3 is 3x square, and minus 5 by 3 into 3 is minus 5. So this would be minus 5. Now change the sign. This would minus, this would be plus, and if I add, I would get 0. Since minus root 5 by 3 and root 5 by 3 are the zeros of the polynomial, when we divide the polynomial with the factors, we get remainder as 0. So the second part of the question, the quotient are the other roots of the polynomial. So the quotient we got is 3x square plus 6x plus 3. So let's write it below. 3x square plus 6x plus 3. It's equated to 0 to find the roots. So we can take 3 common here. X square plus 2x plus 1. This would be x square plus 2x plus 1 equal to 0. Now I would divide the middle term. So this would be x square plus x plus 1 equal to 0. Next I would take x common here. This would be x plus 1, and 1 common here. This would also be x plus 1. And if I take x plus 1 common here, x plus 1 into x plus 1. So the other zeros are, this would be, if two numbers multiply to get 0, either of the two numbers should be 0. So x plus 1 equal to 0 or x plus 1 equal to 0. Therefore x equal to minus 1 or x equal to minus 1. So the other two zeros of the biquadratic equation, the biquadratic polynomial they gave is minus 1 and minus 1. So I would write the therefore statement as, if minus root 5 by 3 and plus root 5 by 3 are zeros of this given quadratic polynomial, biquadratic polynomial, then the other two zeros are minus 1 and minus 1. The fourth question of exercise 3.4. So it says, on dividing x cube minus 3x square plus x plus 2 by polynomial g of x, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. So we need to find g of x. So in this question, we would be using the division algorithm, which says the polynomial, the dividend is equal to divisor into quotient plus remainder, right? So to find the g of x from this equation, I would equate the g of x from this equation. So this would be, if I bring this plus r of x to this side, it would be minus r of x. So p of x minus r of x is equal to q of x into g of x. And if I divide and to say bring the q of x onto the left hand side, it would become division. P of x minus r of x by q of x is equal to g of x. So to find g of x, we need to subtract the remainder from the dividend and divide the whole thing by the quotient. So first, let's subtract the remainder from the polynomial. We have x cube minus 3x square plus x plus 2, x cube minus 3x square plus x plus 2, and the remainder is minus 2x plus 4, so minus of minus 2x plus 4, and the quotient is x minus 2, right? So if I open the brackets and simplify it, it would be x cube minus 3x square plus x plus 2 plus 2x minus 4 by x plus x minus 2. So x plus 2x is 3x, x cube minus 3x square plus 3x minus 2, sorry, plus 2 minus 4 is minus 2, and we need to divide the whole thing by x minus 2. So now it's just division of polynomial. So x cube minus 3x square plus 3x minus 2, dividing it by x minus 2. So how do we divide two polynomials? We have three steps. First step is, we need to find a term that is to be multiplied to the first term of g of x to get the first term of p of x, right? So what do we need to multiply here to the first term of g of x, that is x, it to become x cube. So I need to multiply x square here. So x square. Now second step is we multiply the term we found to all the terms of g of x, right? So x square into x is x cube, and minus 2 into x square is minus 2x square. And now next step is which change the signs. If it is plus, we change it to minus, and if it's minus, we change to plus. This should be plus, this should be minus, and this is minus, so this should be plus now. Now add them. So x cube minus x cube is 0. Minus 3x square plus 2x square is minus x square, and this would be plus 3x. Next, same, repeat the procedure. The term that is need to multiply to the first term of g of x to get the first term of p of x now. Now we have first term of p of x is minus x square, and here first term of g of x. So we need to multiply it by minus x, right? So if I multiply it by minus x, it would become minus x square. So now multiply all the terms of g of x with the term we found. X into minus x is minus x square, and minus 2 into minus x is plus 2x. So now change the signs. If it is minus, it would become plus, and if it plus, it would become minus. So this would be plus and this would be minus. Now add them. Minus x square plus x square 0, and 3x minus 2x is x. And finally we have minus 2. And what do we need to multiply to the first term of g of x to get first term of p of x? 1. So since they are both are equal, we need to multiply by 1, right? So it would be x minus 2. Now change the signs. This would minus, this would be plus, and remainder is 0. Since we got the quotient x square minus x plus 1, that is the answer of the division. So by dividing the x cube minus 3x square plus 3x minus 2 by x minus 2, we got the answer as x square minus x plus 1. Since the division gives us the answer, this is only the g of x. This is the g of x. So the therefore statement would be, on dividing x cube minus 3x square plus x plus 2 by polynomial x square minus x plus 1, the quotient and the remainder would be x minus 2 and minus 2x plus 4. Fifth question of exercise 3.4. You have to give examples of polynomials p of x, g of x, q of x, and r of x. They satisfy the division algorithm, and degree of p of x equal to degree of q of x, degree of q of x equal to degree of r of x, and degree of r of x equal to 0. So, what are the p of x, g of x, q of x, and r of x? Well, p of x is the dividend, g of x is divisor, q of x is quotient, and r of x is remainder. So they give different conditions, such as the degree of dividend should be equal to degree of quotient should be equal to degree of remainder, and degree of remainder equal to 0. So for the first case, to satisfy, let's take so we have degree of dividend is equal to degree of quotient. So for the first case, to satisfy, if we take the divisor any constant term, if we take the divisor any constant term, then degree of p of x will be equal to degree of q of x. So let's see the example. Let p of x equal to 2x square minus 2x plus 14, and divisor equal to any constant term is say 2 here. And if we divide the both of the equations, the degree of dividend equal to degree of quotient. So let's divide them. 2x square minus 2x plus 14 dividing by 2. So the procedure to divide two polynomials is, find the term that is to multiply to the first term of g of x to get first term of p of x. So first term of p of x is 2x square, and first term of g of x is 2. So what is the term that is to multiply to 2 to get 2x square is x square, right? So multiply x square, we get 2x square, and change the symbol from if plus to minus, and minus to plus. So minus, so this should be 0, bring this down, minus 2x. Same procedure. What is multiplied to 2 to get minus 2x? So we would multiply minus x, right? So this minus x would become here. minus 2x, change the symbol, you would get 0, bring the 14 down, right? So it's directly simply 2 sevens are 14. 14, change the symbol, this would be 0. So if you can see here, the degree of polynomial, the degree of p of x that is dividend is 2. Highest power of x is 2. The x square is a quadratic polynomial. And we got quotient x square minus x plus 7, which also has the highest power of x equal to 2. So degree of dividend is equal to degree of divisor. Next one, second one we have, that is degree of the quotient should be equal to degree of remainder. For this to happen, let's take for second question, let p of x is equal to x cube plus 3x plus 2 and divisor equal to x square. Let's divide the both, x cube plus 3x plus 2 divided by x square. Same procedure. What is the thing that is to be multiplied to the first term of g of x to get first term of p of x? Well, first term of here x is cube and first term of g of x square. So I'd multiply x, right? So multiply by x. So this should be x cube. Change the sign, add them, bring the next one down. So I would bring 3x plus 2 whole down because we stop division when the degree of the remainder is less than degree of divisor. We stop the division when degree of remainder is less than degree of quotient. So since we can see here degree of quotient is 2 and degree of remainder is 1. So we stop the division here. Since you can see the degree of quotient is equal to degree of remainder. Degree of remainder is 1 and degree of quotient is also equal to 1 since the highest power of x is equal to 1. And lastly we have third one, degree of remainder is equal to 0. So for this to take place, same, take any polynomial. It can be cubic, it can be polynomial, sorry, I mean to say it can be quadratic. Take any polynomial as dividend and same like the first one, divide the polynomial by any constant term. So let's take a cubic polynomial here. Let's take p of x is equal to x cube plus 2x square minus x plus 2. Let's take 2x cube, right? So nothing can happen. Next we have, let's take the divisor as constant term, same 2 here. So if I divide 2x cube plus 2x square minus x plus 2 with 2, same procedure. What is the term that is to be multiplied to g of x to get first term of p of x? So I'd multiply x cube, right? So x cube, now multiply all the terms with the term, change the sign, add, bring the next one down, 2x square. The term that is to be multiplied to 2 to get 2x square is x square, so x cube plus x square here, quotient. Next multiply all the terms of g of x with the term we found. This would be 2x square, change the symbol, next bring next one down, minus x. So what is the term that is to be multiplied to 2 to get minus x? I would multiply minus x by 2. If you multiply minus x by 2 to x, I would get minus x, right? So minus x, change the sign, cancel out. Next we have 2 below and directly with plus 1 if you multiply, this would be 2, change the sign, this would be remainder we got as 0. See, you can see here remainder is directly 0, that is a constant term. And what is the degree of constant term? So if we take any constant term like say 3, the x corresponding to 3 is x power 0, right? Since x power 0 is 1, the 3x power 0, degree of the highest power of x is 0. So degree of 3 into x power 0 or 3 is simply 0. Similarly, since we got remainder as a constant term that is 0, degree of remainder is also 0. That's it. Hope you understood the question. Subscribe for more such solutions. Thank you.